Hello, good morning. This video is related to the modeling of a stress-driven bridge with the help of LS software. So before going to the procedure, I will briefly describe about the stress-driven bridge. So a stress-driven bridge is such kind of bridge which is similar to a tension structure like a simply suspension bridge whose suspension cable are embedded into the deck of the bridge. From this book reference, this figure shows a clear picture of suspension cable which have a catenary arc behavior. Also, this bridge is supported by the pre-stressed or post-tensioning tendon. From this 3D view, we can see the suspension cables are embedded through the deck, which is called bearing tendon, and at the middle portion cable are called as pre-stressing tendon, or it may be the post-tensioning tendon. The stress-driven bridge may contain different cross-sectional area, where this figure shows some typical sectional view of a stress-driven bridge. Also, we can follow this reference for taking the cross-sectional information. I took the cross-sectional information from this reference to make a model in LS. So now I will show the procedure of LS, and I will explain the necessary consideration during the procedure. According to the specification, I took here only one span for practice model, but a stress-driven bridge may contain several span. So for modeling, I took here the clear span is 100 meter. The bearing cables and the pre-stressing tension cable diameter I took 50 millimeter. All cable load is 2 meganewton. Gravity load I applied for the deck. Total deck length is 100 meter. Total bearing cable length is 101 meter. Pre-stressing cable length also is 100 meter. Now I will start the procedure. So first of all, I have to open. From here I will select the LS pre-post for modeling the geometry, assigning the material properties and sections, applying the load, and assigning the constraints, contact and other things, and then I will run and we will go the result through LS post processing. So now I have to draw the cross-sectional view or cross-section of deck. So I will select 2D mesh, and from here I will draw through the line. So I need to select this one because I have to draw the line with 2 point, assigning the 2 point. So for this I will follow this dimension. Now I have to connect this parts with the peak. Then we have to divide the all the lines through a several element. So I need to select this one. Then first of all I want to divide into two element, so I select two, and now I will select the lines that I want to divide into two element. So this two I select, and I also select this four similar. Then I want to divide the three elements, and I select these two lines. Now just one, according to the convenience. So this line is very uh, uh, almost bigger line, so I will divide this one in 8 equal elements. So I select this one. This I have done because it will help us to make the machine. So now I will create the machine. So first of all we have to see which kind of area we need to select first. So we will see this one is the 4 edge area, so I will select this one. This is 4 edge area. It is form like which kind of mesh it will create, because I divided this line into 3 element and this line into 2 element. So I will accept this one, and you can see this is meshing already created. And now I will go this box. This is contains 4 edges, so I will select this one. And now this one is 4 edge. This one is more than 4 edge, so I will select this one. Except again I need to select this one, because this one contain 4 edges. So now the machine is finished. I have to exit this one. Now this is the sectional view update with meshing during in LSDyna. For after generating the mesh, it creates a new part here, finite element part. So after creating the part, no need for the geometry file further, so I deselect this one. Later I will delete this one. And then we need to do the duplicate node, because if the same edge select for generating a mesh, for the common edge will generate the two node duplicate at the same point. Due to this reason, duplicated node should be merged. We need to do this one by element tool options. We have to select duplicate nodes. Then as this was by part, select this one, show the duplicate nodes. These are the duplicate, so merge, we need to merge nodes and accept. Done. Now this session is ready for extrude to draw the 3D view. So well, we can see this one shows the y-axis, x-axis is this, and z-axis is the perpendicular of this surface of this window. So I want to the x-axis along the extrudal portion, that means the length of the bridge, and z-axis should be the vertical portion. So I will rotate this one, or you can keep this one at this situation, but during the extrude and another assigning the length, you have to keep in mind this axis. So I have to select the transform, rotate I need to select. So I have to rotate the y-axis at 90 degree. So first of all I have to pick the origin, and this will show the node number ordinate of this point, and I will select just simply 90 degree rotation by part. All the parts I need to rotate, so I did this. So it's automatically rotate 90 degree along with respect to the y-axis, and I also select the z-axis rotation and rotate. After rotating this this part need to extrude now, and we can do this one by selecting the element generation, and the deck will act as solid element, and solid by drag we have to select. And when I rotate, I told that x direction we need to extrude. So if I will select this one, this will extrude along only x direction, y and z direction is 0. So as I told before that our span is 100 meter, so the length of the bridge is 100 meter, and segment I did here 200 number. So when I will create, I have to select a part, because all the parts I want to extrude. So this already extruded, and after that I accept and done. Now I will draw the cable, bearing cable. Before doing that, I will select the shape group because I don't need, and delete this one. And then I went to the FM parts. Here S1 is the surface, which when I deselect this one, the surfaces disappear and we don't need this one, so I delete this one. And we have to rename this 3D deck as deck part. This generated deck I will list it in the part by selecting the keyword, and here as part ID 1. Then I will go to curve and line, because I will draw the cable as a line. as the length also belongs to the x-axis, so I will draw this one as 1 and 101 in x-axis. So this is start point is 0, end point is 101. This should be 0. Apply, it's already created, so I will close this one. If we want to see, we will deselect this deck part and we can see the cable. Then we will do the mesh. Element generation can be go through by mesh, and here now we have to select the beam, and beam by curve we need to select, and this time the third node is Z, so I will select this one, and the element number I will put as 1010. You have to select this one and create, accept, done. This is shown that it is divided by the number which I input. So we will go to V, and beam prism we do deselect so that it will convenience for us for seeing the cable. Then I will rename this one as part. Now we will apply the deck part, and according to our specification, the cable should be extended 0.5 meter from this surface, and another 5 meter from another surface. So for doing this, we have to translate the bearing cable from its position to deck part. Before going to do this, I will delete this one because we don't need this one. In order to move the position of one part from one point to another, we need to select the translate and select node to node, n1 to n2, where n1 is the node which one we want to move, and n2 is that node where we want to move. Like in this cable, that node which is situated in point 5 from the starting point, we have to select that node, and then we will move this node that position where we want to move. So for this, we have to first measure 0.5 meter distance. We can do this one by select the initial node, and we can search for the node which is situated 0.5 meter apart from the initial node. So this one is 0.4 meter, so I will clear. Then initial, this one is 0.5 meter apart from the initial node, so I will keep it because during the translation it will help us. So at the first node, which node we want to translate, this one, and the second node will be in the deck part. In here we want to translate the position. So all we have to done by part, this part should be selected and then translate, and we can see this one is translated from its initial position, so we can do accept. Done. We need two bearing cables, so we can copy this one and translate at the same time from here to the same position, same opposite position. So we can again select the translate, copy element, following the previous um, procedure. We can do this one now, but this one we have to select because we want the same same material, I mean same part in the in this position, so we can accept and done. Now we will draw the cable part, pre-stressed cable at the middle portion, but so we can do this one by also by translate, where according to the previous procedure we again select the nodes like this, because we will copy this part from here to at the middle portion, and done. Then before going to translate procedure, we will add enlisted this one, we will create this the cable part, so that we can enlisted this part in this playlist, part list. From here we can add third number part is called pre-stressed cable part, accept, done. It is selected part 3, so the translated portion will be named as part 3 cable or pre-stressed cable part. So we will select the first node, then the node where we want to translate, one, two, three, four, here selected already, but this time we will select by element, because if we select by part, this two will be copied, so we will select by element, and we need to select area, because this part is a combination of several elements, so for this we need to select all the elements like this. It is selected, then translate, accept, done. It's already have done. You can see here that is the pre-stressed cable, and also from there pre-stressed cable is the third part of this modeling. So now this is the time to draw the abutment. For drawing the abutment, we will go to mesh, and this time we will not select the 2D mesh, we will select the shape master, because by doing the by selecting this we will directly draw the 3D view of the abutment. So we have to now put the dimensions of the x, y and z. So for this I will go measure again and measure from here to here distance. This one is 2.7 meter. So at y direction it's 2.7 meter. We again go the mesh and select the shape master, and we select this one box solid. This one, and in x direction I just select as 0.6 meter, and y direction we measured as 2.7, and the z direction, that means this direction, we assumed as 2. So we divided this 0.6 meter in 6 division, and this one we select as 20, and this one also 20. Create etc. So we have to place this abutment to its suitable position, and this one we can done again for the translation. As previous procedure, we will select first the N1 node, and this one is this, and the N2 node is this one, and we will select by part. Copy element I will omit now. I will omit now, then translate. It's it, done. It's already into its position. This is one side apartment, then I will copy this one to here to another part, another side of this bridge. Again I will use the transform option, but before that I will measure again. distance looks here 100 meters. So if we select this point, the total length will be 100.6 meter. This one is in x direction, so we got the distance in. We'll do the translate through x direction only, so I select x direction and we put just length and copy element. Then I will select by part and translate. Before accept, we have to see that it placed its position or not. Yes, it's placed its position, so I accept this one and done. I will rename this one as abutment. Now it is turn to assigning the material property. We will go from model to keyword. And for material property, assigning the material property, we will go mat. As you know, the take and abutment is acted here as a solid material, so and we used the concrete for the abutment and deck. So we will select the elastic properties and we will title this one is concrete material, deck and abutment. That means we used the concrete as deck and abutment material. For the concrete material property, we take the portions density is 2400 and Young's modulus of elasticity is 13 to 10 to the power 9 and the Poisson's ratio is 0.2. So when I accept this one, it was take as automatically material ID 1. So done. Then for the next one is cable. In this case, cable and the pre-stressing tension material property will be the same, so we select the cable discrete beam and when we assigning the material, we selected as a beam, so we will go cable discrete beam. So I will title here cable for bearing and pre-stressed, and the material property I took here 7850 as a steel material, 210 e to the power 9 F0 should be F0. What is F0? If we select here, it will be show as initial tensile force, so we selected here the initial tensile force is 2 to the power 6. then we need to select the Tmax F0, time for which pretension force will be held. This one I selected as 2. That means it will end up to 2 second. It will end in the 2 second. And then ramp up time I selected here 10. When I accept this one, it will take as material ID 2. So done this one. The next step is assigning the element type as the pre-stress concrete deck and abutment, and the cables are divided into several elements. So we have to select the elements from the section. Through the section we can select the element type, because during drawing the geometry we assumed the deck and abutment as a solid part, and the bearing cable and the pre-stress as the cable beam part. So from section we select the solid section, and now we will title as deck and abutment. From here I will select 2, because 2 element type will be fully integrated, is our solid stress or strain solid. So this one is enough for selecting the element type. Then accept. It's automatically section ID will be taken as 1. As we insert the dimension during the drawing of this geometry, we don't need to assign the dimension here. So done. Then we need to select the beam type element. Beam type section. From here we will select the element type for bearing cable and pre-stressing cable. So I will title here bearing and pre-stressed cable. In this case, to defining the material property, we have to select the 6. From 6 we can get this one, discrete beam or cable type element, and then we have to select the QR or IR ID. What is QR and IR ID? Quadratic rule or rule number for user defined rule for integrated beams. So we took 2 because 2 will take the 2 by 2 matrix. It will form the 2 by 2 matrix for the nodes. And as we did not input the diameter of the cable during the drawing, so we have to now input the cable area here. I calculated before, considering the 50 millimeter of dia, the area is 0.01963 meter square. And the CST will be 1 will be tabular. So this is enough for the element type selection for the bearing and pre-stress cable. I will accept this one. Now this is time to assign the boundary condition or support condition at the abutment. This one we can done by create entity, where the boundary condition, there are three type of boundary condition. We will select SPC means single point constraint. That means we will select all the single points where we want to insert the where we assign the support condition. So for this we need to create this one and select the node set. We'll select area. I took this view because with selecting this from this side, the both part of the bottom surface will be selected at a time. So this kind of support condition will contain the degrees of freedom in all direction, and also the all directional rotation degrees of freedom is also 1. So I apply this one. Yeah, you can see this, all the points, specific points where the surface of the abutment is shown here, the both side single point constraint whose degrees of freedom in each axis is 1, and also the rotation of already create the material ID and sectional ID which containing the necessary information about the material and element type. Now I will assign the material and section for each part by selecting this one. At first it is selected as deck part ID is 1. Then sectional ID I will select the deck and abutment because deck part is made by concrete. Done. And material ID also concrete deck and abutment. Bearing cable, sectional ID should be bearing cable and pre-stressed cable. Material ID also should be cable bearing and pre-stressed, except pre-stressing cable is similar to the bearing cable. Then for abutment is similar to the deck part. Deck and abutment material should be deck and abutment, and the material ID, section ID should be deck and abutment, except done. Then the material ID and the sectional property assigning is finished. Now this is time to make the constraint between the deck and the cable. In the constraint part, two types of constraint we need to select by here. Both of the cases we will select the beam in solid because the cables are cable part are acted here as beam, and the abutment and deck part is acted here as solid. So one is the cable embedded in abutment, one kind of constraint, and another one is cable in deck. So we will select this one first, and then we will name the title one by one, and assigning the other things. First of all, we will make the constraint title as bearing to deck, where all the all we took as part. So we will select the master set type of 1 and master set type slave set type also 1, and also we will select CDIR is 1 because when the cable is embedded in the deck, they should not be acted as monolithic type. So to omit the coupling between the cable and deck in the same direction of the cable, we need to select 1, so that when the cable is loaded, or when the deck is loaded, the cable should be go through along the axis of the cable. So we have to select 1 for when we select the bearing to deck, or when we select the pre-stress to deck. So for this one, slave should be bearing cable, and master should be the deck part. When we accept this one, this coupling ID is automatically generated as 1. So for the next coupling ID, we need to add, and here we have to title pre-stressed to deck. In this case also we have to select part, and CDIR is 1, because in this case also the pre-stress and the deck should not be acted as monolithically, and the pre-stress should be move along the axis through the deck, and the slave will be here pre-stress cable, master will be deck part. So I accept this one. So 1 and 2 is already 1 and 2 constraint is already created. In the second kind of constraint, we have to select the cables embedded in abutment. We need to title the bearing to abutment, and for this the slave will be bearing and master will be the abutment. These will be the same, and CDIR this in this case will be 0, and we have to accept this one. After that, this kind of constraint also assign for the pre-stressed to abutment, where all the things will be same except the slave should be pre-stressed cable. So this we also need to add. Now the constraint is finished. The bearing cable and the pre-stress cable with abutment and the deck has been finished, but we have to connect another contact between the deck and the abutment. We need to done, so we will go here the contact, and only just surface to surface contaction is okay, so we will select the automatic surface to surface. Automatic surface to surface, where we have to select the ID. We select the SSID gap through 3, and in is the type is 3 also. So SSID here will be the take ID, and master should be the abutment. Here, because of frictional force, we will take the friction coefficient for Fs is 0.2, and for Fd is dynamic case is 0.1. So this is all the information for contact between abutment and deck. You can see from here contact, and the constraint being solid, so 4 parts. Contact is automatic, surface to surface, element is 2 type, mat here 2 type, part here 4, section 2, this. Now we need to define the load. For this we will go here and select the load type. Load type, where we will take the gravity part only. Here the degrees of freedom we took 3, and load curve, for gravity load curve we have to select this one, new keyword, and as we will select as gravity load curve, we need to define from here. Where is the IR stress initial by dynamic relaxation, we need to select this one as 0, and SFA scale factor for abscissa value, we will select here as 1, and ordinate value is also 1, and the A1 value should be here, we selected as here at first 0 and 0 at the initial level, then insert this one, after 3 seconds in abscissa it will start, then we will insert this one, and then up to the 10 seconds it will increase up to 1. insert this one, and this will define our the gravity load curve, which we can see from here. Plot set this one at first, then read and plot. Now we can see at first the abscissa and the ordinate was 0 time the load is 0, and then at the 3 second it starts, and up to 10 second it increased up to 1. So this is our load curve, gravity load curve. Save this one. All the main things have been done in this stage of stress response bridge modeling. Now we need to select the analysis type through control and ls Tahmina. If we don't select any analysis type, it will automatically default setting is explicit type, but we need to select the termination time, or up to when it will will terminate it. That is, we can select this one from control. Termination, just on a termination. End time, we need just input the end time. Means after 10 second analysis will be finished. Termination point, then terminal time set, sorry, time step. It will take, we need to input here this one. This is called the time step size for mass scale solution. It will we select as less as we can, which will scale down the time to a mass scale, and the time scale is used for the quick solution, and it needs less time to solve the problem. Then at the last one we have to select the database for selecting the time interval. We will select here as binary D3 plot. Time interval I will put here 0.05, and other thing we don't need to do. And this one is accept and finished all the procedures. Then I will save this model in a suitable directory.